You get to take a break from radicals for at least today. I don't really remember what 7.7 or 7.8 is yet. But for now, for 7.6, you get to take a break from radicals. And what we're doing is putting functions together. All right, so the first half of the notes is about function operations. That's when we take two functions. Remember, functions are equations. And we'll add, subtract, multiply, and divide them. All right, this part's pretty simple. You just kind of plug them in and simplify. Remember that f of x, g of x, anything of x, whatever it is, that is a name. That is not multiplication. It is just a name that you will replace with the equation that goes with it. So if you see things like this, just know you can go back and forth between them. If it's parentheses f plus g of x, that's the same thing as f of x plus g of x. All right, so you can combine the f and g in parentheses and the x separate, or f of x over g of x. Okay, that makes sense? The only tricky thing about this is division. All right, in division, your denominator cannot equal 0, as usual. Remember, calculator says error, and then it catches on fire and blows up when your denominator is equal to 0. So just remember, denominator can't equal 0. As we go through these, we're going to talk about their domains. Most of them, the domain will be all real numbers. Okay, so if you get confused, that's probably a good guess. The domain of some difference product and quotient functions consist of the x values that are in the domains of both f and g. X values and both for the first sentence. All right, so if f of x has domain of all real numbers and g of x has domain of all real numbers, and we're putting them together by adding, subtracting, multiplying, or dividing, then the domain of the answer, the combination of both of them, would be all real numbers, because that's what they started out as. However, of course, for the quotient one, it's a little more complicated. The domain of a quotient function cannot include whatever would make the denominator equal 0. So does not contain any x value for which g of x equals 0, because g of x is the denominator. X value. Okay, it may not always be g of x. They may switch it around, but just know it's whatever the denominator is. All right, we'll see that the very last problem on this front page. All right, so let's start. It tells us what f of x is. F of x is 3x plus 8. G of x is 2x minus 12. First of all, we need to find f plus g and their domains. All right, so we're going to do f plus g. Okay, looking right now, what kind of graph would 3x plus 8 make? Linear. It's linear. It's just a line, and lines go forever and ever and ever, right? So the domain is all real numbers. What about this one? It's also a line, right? So you already know that the domain for this problem, the answer, is going to be all real numbers. Y'all remember that fancy R? The double bar? All right. So we already have that part done. Now we just need to do the addition. Replace the f with its equation. So that'd be 3x plus 8 plus, replace the g, 2x minus 12. Since it's addition between those parentheses, the parentheses really don't even make a difference. So if you want to write it without them, you can. That helps you see it better. We've got 3x plus 8 plus 2x minus 12. Add like terms. 5x minus 4 is correct. If you want to like write your answer part together, be 5x minus 4, comma, all real numbers. So that is f plus g. Simple enough. Okay, the second half of that problem is that we're supposed to subtract them, f minus g. So remember that the domain is whatever both of them are, which is all real numbers again. We already know that. And now we write them out again, f, but this time it's minus g. Make sure you put them in parentheses because, like on this one, we have to distribute that negative. So we get 3x plus 8 minus 2x, and then it'll be negative times negative is positive 12. Three x minus 2x gives you just x. 8 plus 12 gives you 20. And you can write your all real numbers with it if you want, instead of having to box in two different things. Simple enough. Okay, pay attention to the order that they give it to you in, because if they would have said g minus f, we would have had a totally different answer. Okay, so you have to plug them in the right order. Any questions? All right, the next part is the multiplying and dividing, and we have new equations. Okay, so we're going to start with f times g. Okay, let's look at the domain here. That is a parabola and a line. So again, like I said, we're usually going to have something that'll go on forever and ever. So our domain, again, is going to be all real numbers. And now we just have to simplify things out. X squared minus 1 times x plus 1. What are we going to have to do to this? FOIL is right. All right, so first times first gives us x cubed. Yep, x to the third. Outside times outside. X squared. Okay, inside times inside. Last times last is negative 1. Any like terms there? No, all the exponents are different, so we can't combine any of them together. So that with your all real numbers is your answer.
Is it always going to be all real numbers?
For
just right now?
Pretty much, yeah. Except for the division ones. Those are the complicated ones, which we're about to do one of those. Do 2 bars, and then do the last one. Is what I do.
I think it's easier to just do the R and then have the one.
That'll work too. Okay, so the next thing says f divided by g. So we're still on the front page on example 2. So f, remember, is x squared minus 1, and g is x plus 1. So the domain on these, it's still like whatever the domains are put together, except you can't have anything that would make the denominator equal 0. So our denominator is x plus 1. That cannot equal 0. So what can x not be? Negative 1. Okay, so there's our domain. It's real numbers, except x cannot be negative 1. Now, sometimes we will be able to cancel things from the top and the bottom, and sometimes we can't. As of right now, the way it looks, we cannot. All right? We have an addition sign with this x and a minus sign with this one, so you can't cancel those two x's, though all of you would like to. You cannot. But what we can do is try to factor the top, since it's a quadratic, and see what happens from there. So a times c is -1. What's b?
0.
0 is correct. So what multiplies to get -1 adds to get 0?
-1 and 1.
-1 and 1. Okay, so my little fractions will be -1 over 1, 1 over 1. Can't reduce those any. So my factors are x minus 1 and x plus 1. So I'm going to write those up at the top. If we were trying to solve the top, then yes, but we're trying to see if we can cancel something out. Which can we? The entire factor x plus 1 cancels out, top and bottom. So our answer is x minus 1, and all real numbers except x can't equal -1. That's supposed to be -1. Looks funky. Sometimes you will be able to cancel things out. Sometimes you won't. Okay? And remember the whole domain thing that the denominator can't equal 0. So at the beginning, look at it and say, what can this not be? Any questions on function operations? Okay. Let's go to the back. Now, composition of functions is a little more complicated. This time, we're actually going to put one function inside the other one. Okay, it's like composing things, like when you compose food or music or something, like you're combining things together, right? And it's like all woven together. Okay, that's what's happening with functions. We're going to put one inside the other one. It looks like these, okay? That's what it looks like. Most of the time you will see it with this little circle thing. It kind of looks like a degree symbol, but it's not like up high. It's down in the middle. Okay, so that you read that as G composed of f of x. G composed of f of x. This is also another way to look at it. Okay, it's same order, G, f, and x. They say in the same order, but we don't use our symbol. But you see that f of x is inside the G function. Okay, so f is our inside function, G is our outside, which you can look at it the same way here. F is the one close to x, so it's our inside function, and then G is our outside function. What we're going to do is solve the inside function first. Okay, so inside, when it says first function, it means the inside function. When it says second function, it means outside function. So we're going to solve the first function and get an answer, which we call our output. Okay, so if you want to write answer down below that, that's fine. Our output of our first function, we will then take and put into our second function, so it becomes the input of the second function. Like that's what we're going to plug in for x. I will show you how this works. This thing is kind of confusing and I don't really like it. You can look at it if you want to, but I don't think it's worth talking about. Okay, so example 3 says let f of x equal x minus 2 and g of x equal x squared. Find g composed of f of -5. So remember, inside function goes first. So what do we need to do first? This right here, f of -5. All right, so deal with whatever's closest to the number first. If we're trying to figure out f of -5, what do I plug that -5 into? You've done problems like this since like middle school. This whole f of -5. It's in for x, right? So we have negative 5 minus 2. All right. The x minus 2 right there gave us, if you want to put parentheses around it, you can. So f of negative 5 equals negative 7, because it was just subtraction. Good so far? Now, this g part, that's what we do second. So g of, use the answer from the first part. So g of negative 7 equals, it'll be negative 7 squared. Because you replace the x with the negative 7, which equals 49. So that is your answer. Just remember, whatever's next to the number, you do that first. And then, whatever was away from the number, you use your answer to figure that one out. It's like what we did, let me write it out the other way. Okay, the other way to write it is like this. So we figured out that f of negative 5 equaled negative 7. So we replaced, don't do that. We replaced that f of negative 5 with negative 7, and then we figured out that that was 49. Does that make sense? We just replaced this entire thing with negative 7. I think that way is easier to look at, but they're going to write it like that with the little dot thing, circle, degree sign looking thing. Any questions at the moment? Okay, let's try another one and see if it'll like kind of clear up a little bit. For the same f of x and g of x, so we're still going to use the x minus 2 for f and x squared for g. Find f composed of g of negative 5. So what problem do we have to figure out first? G of negative 5. Very good. Okay, so this is first. Let's see. G was x squared. So I'm going to have negative 5 squared, which is 25. What do I plug that into? Yes, f of 25 equals, what was it, x minus 2? So 25 minus 2 equals 23. So order definitely matters because we used the exact same equations and plugged in the exact same thing to start out with, but got two totally different answers.
So we always do x equals x minus 2 and g of x equals x squared? Would always be that?
They'll tell you at the beginning of the problem. Like each section of problems has its own what f equals and what g equals. So definitely pay attention to it. Because when you like switch sections of problems, they're going to switch the equations on you. All right. Any questions? No? All right. The first chunk of your homework is the operations, and the second chunk is the composition. So if whichever one you find more difficult, maybe work on that first while you're here to answer questions. Also, tomorrow, I have parking lot duty in the morning, so I will be in here until 7:35, and then after that, I go outside. So if you want help inside the building, come before 7:35. If you don't mind standing out in the cold, you can go stand out there. Or you have other teachers around. Is that what you're pointing at? Yeah.